Enormous, greater than the huge Jupiter, with a width of nearly 140,000 kilometers, the ruler of our planetary system is so huge that the Earth would hypothetically squeeze into it more than 1,000 times at the same time. The huge gas monster is around 2.5 times more enormous than the wide range of other 7 planets in the planetary system combined. But did you know that the planetary giant is a real rapid Gonzalez? Despite this, in fact, Jupiter only needs slightly less than 10 hours to turn around its own axis, making it the fastest rotating planet in our home world. But, beside its charming beauty, Jupiter is also the scene of giant storms and lethal radiation. What secrets lie hidden underneath its thick clouds of mist? What do we know about the Great Red Spot, which is bigger than Earth and whips across the planet's outer layers at a crazy speed of up to 680 kilometers per hour? And, overall, how could our own planet never have appeared if Jupiter hadn't been rampaging through the solar system like a frenzied berserker? In the beginning was Jupiter? Well, essentially, that applies to the development history of our planetary system. A few years ago, scientists at the University of Beast were the first to successfully determine the true age of the imposing gas giant. However, since the celestial body has no solid surface and hence cannot provide rock samples, the researchers had to take a little diversion in their age calculation and reach their conclusions from shooting stars. The main point, however, was the realization that Jupiter had grown to 20 Earth masses in less than 1,000,000 years after the formation of the solar system, and that its development was completely finished after another 3 million years. By comparison, the Earth, whose mass is 318 times smaller than that of Jupiter, took a whopping 100 million years to reach its planetary completion. And while the powerful divine body isn't just the biggest but also the oldest planet in our home system, it was once formed from the dust and gases left over from the formation of the Sunday, April 6 billion years ago. A stockpile of material that is also reflected in the composition of Jupiter. Much like the Sun, the gas giant is primarily made out of hydrogen and helium, which unexpectedly also explains its nearly low mean density of 1,330 kilograms per cubic meter. But despite the fact that the Sun and Jupiter are undoubtedly cut from the same fabric, there is now an average distance of 778 million kilometers between them. To be precise, the 2 XXL planets orbit beyond the asteroid belt, between the orbits of Mars and Saturn, and thus the group of stars all takes under 12 years to circle our central star. Well, strictly speaking, that is not entirely accurate either. Since, if we are very meticulous about the facts, Jupiter does not orbit the Sun at all. But what is meant by that? Well, to understand this, we need to bring a little diversion into the universe of barycenters. The barycenter describes only the center of mass that planets and stars orbit together. This is typically closest to the object with the greatest mass. And since the mass of the Sun is 330,000 times greater than that of the Earth, the barycenter in this case is extremely close to the center of our mother star. However, as already mentioned, Jupiter is much heavier than our home planet, and as a result, we find the center of gravity of Jupiter and the Sun not at the center of our home star, but right outside the outer layer of the Sun. Jupiter wanders off as a result. The greater the mass of a body, the stronger its gravitational pull on another body, and since Jupiter has a lot of mass, as mentioned, we are talking about a significant degree of around 318 Earth masses. Its gravitational power impacts the structure of the solar system in various ways, and that starts right at home. We now know of 95 moons that are bound to Jupiter's gravitational hold. But that's not all. The subglacial sea of Jupiter's moon Europa is even thought to harbor extraterrestrial life. However, further investigations should show how much this astonishing theory eventually matches reality. So far, the gas giant has been the center of test-based research missions and flybys multiple times. In fact, the NASA probe Juno is still dedicated to the task of investigating the Jupiter system in detail. What's more, the scientific support is already on its way. The ESA probe JUICE set course for Jupiter on April 14, 2023, and is scheduled to reach the gas giant in July 2031. Up to this point, so mission-focused. But if we now return to the strict fascination of the gas giant, we see that its gravity surpasses that of the Earth by more than 2.5 times, and that Jupiter thus also serves as a kind of natural defense. In general, due to its significant mass, its huge gravitational field deflects comets and asteroids that could otherwise hit Earth. In other systems, however, proximity to such large planets is not always an advantage. One study concluded that the attraction of the planetary giants not only redirects risks, but also sometimes launches smaller planets out of the habitable zone. And speaking of being catapulted out, Jupiter too has a history as an enormous wrecking ball. Scientists now expect that the gas giant was initially formed much farther away from the Sun than its current orbit suggests. Furthermore, there have long been signs that Jupiter even briefly relocated into the inner planetary system. And in doing so, on the one hand, it caused unparalleled chaos, and on the other, it enabled the Earth to form the corresponding recreation. Researchers showed that the gravitational pull of Jupiter's movement carried enormous amounts of debris and planetary building blocks with it. We're talking about there are planetesimals up to 1,000 kilometers in size and a sum of 10 to 20 Earth masses of material. However, it's in the nature of things that this planetary stroll of a fairly unique kind did not stay without outcomes. In light of the fact that it really set off a genuine chain reaction of asteroid impacts, which obliterated larger planetary cores, and furthermore, made an enormous piece of the debris dive into the Sun. The once extremely thick growth circle near the Sun was subsequently seriously dispersed in the impacted district, and the situation only quieted down when Saturn formed farther and Jupiter switched its movement course. Because of this, Jupiter's passage cleared the inside of the early, nearby planet group, leaving it empty. Consequently, it cleared the way for the second wave of development of small, rocky planets. Furthermore, our Earth was also among them. However, this situation is also ready to give an explanation for the peculiarity of the solar system. In scarcely any other known systems do the deepest planets begin as out of sight and have as little gas as our own. Rather, most extrasolar gas giants or super-Earths orbit their host stars very closely and rapidly, and they often take only a few days or months to complete an orbit. Why the Great Red Spot shudders, though, is still not fully understood. But if we now isolate ourselves from the tempestuous history of Jupiter and instead investigate its optical appearance, we immediately notice the strange region of the planet. What at first might look like a stylish striped design is actually a series of nearly parallel bands of clouds, which can be seen even through small telescopes. These bands range in color from white to blue, and scientists recognize the lighter zones and the darker belts. While the lighter zones are cooler and denser than their counterparts and also contain rising gases, their lighter tone is likely due to ammonia ice. The reason the belts appear darker is not yet fully understood, but scientists expect that phosphorus, sulfur, and maybe even hydrocarbons are present in them. Surprisingly, scientists have noticed an occasional variation in the prominent bands every 4 to 5 years, which might be connected with cyclic motions of Jupiter's magnetic dynamo. Moreover, the zones and belts are limited by alleged planes, which race over the outer planetary layers at wind speeds of about 300 kilometers per hour, compared to the speed of the Great Red Spot. That isn't anything, though. The largest tornado in the entire solar system actually moves at speeds of up to 680 kilometers per hour. However, it's not known which chemical elements are responsible for the red hue that gives the Great Red Spot its name. What is known is that the huge anticyclone is currently around 1.5 times the diameter of the Earth and has been raging on Jupiter since at least 1830. By comparison, the wind vortices in Earth's atmosphere typically have a much shorter lifespan. Despite its extensive age, the Great Red Spot has now contracted considerably. While its length was still estimated at 40,000 kilometers during the 1880s, it is now only 16,500 kilometers. NASA believes this is due to interactions with other smaller storms. Could its own deficiency of size also be the reason why this immense structure is literally shaking? Probably not, but groundbreaking observations with the Hubble Space Telescope have recently shown that the Jupiter storm changes its appearance several times during its 90-day movement from east to west and back again. The Great Red Spot, on the other hand, limits and enlarges as it floats faster and slower. These motions also go hand in hand with occasional variations in the size and brightness of the storm's eye, which are inversely related to the drift rate. In fact, the Great Red Spot and its eye are at their largest and brightest when the hurricane is drifting at its slowest. The characteristic changes slightly from day to day, and in time, it looks as though the Great Red Spot is shaking like a leaf. But why is that? Well, we don't know. However, this is the first time such a swaying has been seen in a Jovian tornado. The researchers have yet to provide the corresponding hydrodynamic explanations. However, the assumption is that it is due to interactions with the fierce shear winds of the storm bands north and south of the Great Red Spot. In any case, what will happen next, given the past decreases in size? What are the chances that the huge design will one day totally vanish from the Jupiter scene? Well, this is precisely the question that scientists are currently addressing. They now need to find out in detail whether there is a lower size limit beyond which such a lasting hurricane becomes unstable. How many more shrinks will make the storm's dynamics unstable? We hope you enjoy participating in our scientific exploration and never miss a new video from us. Again, we'll see you soon.